All right, let's do another one of these optimization problems. This one says, and forgive the eraser marks, I made a mistake last time I did this video. See, so even teachers make mistakes. We want to maximize the objective function q equals xy squared. So remember, our optimization function is what we're minimizing or maximizing. X and y are positive numbers such that x plus y squared equals 9. So this one is our constraint, and we're trying to maximize our objective function. Just like last time, the first step is to solve your constraint for one of your variables. So I think you'll agree with me that this is equal to, if I move the x over, if I move the y squared over, I'll get x equals 9 minus y squared. So that's good. Solve it for x. And then we're just going to take that value and plug it in for the x right there. And when I do that, I get q is equal to, replace x with 9 minus y squared, and then we have the y squared on the outside like that. That's it. Let's clean this up a little bit. This will be 9y squared minus y to the fourth, like that. And now we just take the derivative. So q prime is going to be equal to 18y minus 4y to the third. And so there we go. And now it's just a matter of solving this for all the values of y. Set it equal to 0. I'm going to go ahead and factor out a y. And so I get 18 minus 4y squared. So just take a second to look at what I did right there. All I did was just factor out a y, and we set the first derivative equal to 0. I know I'm going a little fast, but if you need to, just rewatch that part. So that means our first answer is y equals 0. And then we need to solve the equation 0 equals 18 minus 4y squared. All right, let's solve that equation. Add the 4y squared over. 4y squared equals 18. Divide by 4, divide by 4. We get y squared is equal to 9 divided by 2 if I take the, if I reduce. And so let's take the square root. Y is equal to positive or negative 3 divided by the square root of 2, which of course is equal to positive negative 3 root 2 over 2 when you rationalize the denominator. I went kind of fast through that, so if you need to recheck any steps, go ahead. But let's go ahead and look back at what our question was. We want to maximize this function right here. All right, well, we know that one of our answers was 0, but if we let y equal 0, then that means that this function is going to equal 0, and it doesn't matter what x is. In fact, x will be 9 because y is 0, so x is 9. But that's going to produce a 0, and we're trying to maximize this, so it's probably not going to be 0. By the way, 0 is not a positive number anyway. 0 is neither negative nor positive, so we could have also excluded it for that reason. That just leaves positive or negative 3 root 2 over 2, and notice again that these are positive numbers, so that means we can exclude the negative. So the only number we care about for y is 3 root 2 over 2. And that's going to be our number. So let's go ahead and plug it in to this equation and find out what our x is. That means that x plus 3 root 2 over 2 squared equals 9. So x plus, let's see, that's going to be 9 times 2 over 4. Equals 9 when you apply the square to everything. And so that's going to be x equals 9 minus 18 over 4. And when you do that, you'll get a final answer of x equals 9 over 2. So there you go. Here's your y value. Here's your x value. That adds up to 9 when you do x plus y squared. And if you multiply these two things together, taking this to the second power, you'll get the maximum value that q will take on. That's all there is to this problem. Be very careful about what your constraints are so that you're not doing extra work. And we'll do a couple more examples. See you in the next video.